So this is part 2 of 18.1 and 18.2. In part 1, we talked about the trig ratios, sine, cosine, and tangent, and how we can use those to help us find missing sides. If you recall, right, you need to remember your acronym. So, ca, toa, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In part 2, in the second half of these sections, we're going to use them now to find a missing angle. Okay, so in the first section we were finding missing sides. Now we're going to find missing angles. And how we do that is we're going to do the inverse operation of these, and you'll see those right here. Okay, they have sine, cosine, and tangent, but they also have these little -1 signs right here. And so we read those as sine inverse, cosine inverse, and tangent inverse. And essentially what they act as is the opposite of sine, the opposite of cosine, and the opposite of tangent. Just like when you do addition, the opposite is subtraction. When you do multiplication, the opposite is division. When you do a square, the opposite is to square root something. Okay, that's what these are doing. They are undoing the other operation, the sine, the cosine, and the tangent. So when we have at least two side lengths, we can use these inverse functions to help us find a missing angle. So in example 1, it says find the measure of the indicated angles and round to the nearest degree. So the nearest degree, that means we're looking for a whole number. Okay, so we're rounding to the nearest whole number. And number 1 says find the measure of angle A. So in our diagram, angle A is going to be our theta, right? That's the one that we're focusing on here. So if we look at our triangle, okay, so here's theta, and we're going to look at the two sides that we have. Well, which two sides are those if we're going to label this opposite, adjacent, and hypotenuse? Well, across from theta, we should know is the opposite side. Across from the 90 degrees is our hypotenuse. And right next to the theta is adjacent. So in this case, we should see that we have opposite and adjacent. And so from that, opposite and adjacent, O and A, which function uses O and A? That would be tangent for TOA. So we're going to set this up as the tangent of A, my angle A, equals opposite over adjacent. So tangent of A is 19 over 36. And you'll notice the thing that's missing here is A, right? I want to know what is angle A. So to get A all by itself, here's what you do. You're going to take the tangent inverse of the left side and the tangent inverse of the right side. So on the left side, what happens, just like a square and a square root cancel, or multiplication and division cancel, the tangent inverse and the tangent cancel, and all we're left with is A. And on the right side, we just have tangent inverse of this fraction. And so on your calculator, you'll notice that if you look at the sine, cosine, and tangent buttons, right above them in like light blue ink, right above them you'll see that tangent inverse part right there. Okay, so to do that, to use that function, you have to hit the second key in the top left-hand corner of your calculator. Hit that and then the tangent button, and then that will show you this right here. Okay, once you get to that, then you just type in your fraction. So on your calculator, you should have tangent inverse, and it'll fill in the first parentheses. You just type 19 divided by 36. Close your parentheses, and then that will give you your answer as a decimal. So in this case, it'll give you 27.824. And our problem said to round to the nearest degree, the nearest whole number. So angle A is going to be 28 degrees. And that's it. So kind of the hardest part of these problems is figuring out which two sides you're even using, and then from there, knowing which trig ratio you're going to use. So for number 2, find the measure of angle J. So if we look at our diagram, here's angle J, so that's going to be our theta. So if we label our 3 sides, across from that is our opposite. Right next to it is adjacent. And here's our 90 degrees. Across from that is hypotenuse. So in this case, again, we still have opposite and adjacent, which means we're going to want to use tangent for TOA. So if we go back, we set this up. Tangent of angle J is opposite over adjacent. Tangent of J is 46 over 93. So again, I want to get the J all by itself, so I'm going to do the opposite of tangent, which is tangent inverse, because that will allow those to cross out and leave me with angle J. But since I did the tangent inverse on the left side, we have to do the tangent inverse on the right. And so J equals the tangent inverse of 46 over 93. And so again, put that into your calculator, and you'll find that that should be 26.318, which as a whole number, angle J would equal 26 degrees. Okay. And last one here on this page, number 3. Again, find angle A. This is one, if you want to try this one, maybe try this one on your own. I'm going to go through the entire problem, but if you want to try it on your own, this might be a good one to try. Angle A is what we're solving for here, so that's going to be my theta. Again, label your sides. Across from that is your opposite side. Right next to it is your adjacent. Right across from the 90 degrees is hypotenuse. So in this case, you'll notice it finally changes. We now have an opposite and hypotenuse rather than the adjacent side. And so which of my 3 trig functions uses O and H? That would be sine to make so in the SO ka TOA. So we're going to set this up. Sine of A is opposite over hypotenuse. Sine of A is 5 over 10. And again, I want to get rid of the sine, so I'm going to do the opposite of sine, which is sine inverse. And that helps cancel out the sine. And whatever I do to the left, I have to do to the right. So on the right side, I'm going to take the sine inverse of that fraction. And so on the left-hand side, all we're left with is A. On the right-hand side, we have sine inverse of 5 over 10. And again, you put this in your calculator. You want to hit the second key, then hit sine. And so you should have sine inverse, parentheses, and then 5 divided by 10. Close your parentheses. And so you should get angle A equals a nice round 30. And there's no decimal there, so angle A is 30 degrees. Okay, so that's using our trig ratios and their inverses to help us find missing angles. Now on this second page, this one I'm going to have you do on your own, what you should come out with for angle P, if you want to check your work, okay, angle P will ultimately end up being 57 degrees, okay? So try that. If you don't end up with it, okay, ask about it, please. But you should end up with 57 degrees. If you end up with that, you're good to go. Now, number 5 says write 3 different equations to determine the measure of angle B. Verify that each equation is correct. So we're looking at angle B here. That's our theta. And so across from that is going to be our opposite. Next to it is adjacent. Across from the 90 is our hypotenuse. And so we can set up 3 different equations to help us figure this out. So the first one we can do is sine. So sine of B is going to be opposite over hypotenuse. Sine of B is going to be 6 over 10. And again, to get rid of sine, we're going to take the sine inverse of the left side, take the sine inverse of the right, and so that crosses out on the left, and we're left with B. Sine inverse of 6 over 10. And if you put that into a calculator, I didn't prep this one, I apologize, so give me just a moment. Sine inverse of 6 over 10. So B should be 37 degrees. And so there are 3 different ones. That was using sine. So I want you to set up cosine and tangent and verify that that is actually 37 degrees, okay? That theoretically, right, it's the same angle, it's not going to change, right? It's that same angle on the page. So theoretically, if you do these correctly, finding cosine, using cosine and tangent, you should be able to also end up getting 37 degrees on both of those. Okay, so verify that, make sure that that works, and then you're good to go. And that's kind of one of the nice things is when you have all 3 sides, you get to pick whichever one you want to do. Do you want to use sine, cosine, or tangent? It's up to you. Okay, if you only have 2 of the sides, you're stuck to whatever sides you have. Okay, you have to use the trig ratio with that. When you have all 3, you have some more freedom there. So in what circumstances would we use the sine, cosine, and tangent ratios to find missing side lengths? And when would we use the inverse ratios to find missing angle measures? So again, it's important before each problem, okay? Am I finding a side length or a missing angle measure? Okay, because that'll help you determine which one you're going to use. If you're trying to find side lengths, right, then you're going to use sine, cosine, and tangent. If you're finding angle measures, you're going to want to use the inverses, okay? So it all depends on what the problem asks you for. You have to analyze your problem and figure out what you're looking for. So I'm going to let you actually work on these 2 on your own. But I will give you the final answers here so that you can check your work. And if you have questions, just ask. But determine angle A. You should find that angle A is 32 degrees. So go ahead and work that out and see if you can find that. And then for the second problem, the length of XZ, you should get to be 7.99 feet, or if you want to round that to the 10th place, 8.0 feet. Okay, but you should be able to find that. Okay, so if you have any questions with those, let me know. But otherwise, hopefully that will kind of help you check your own work there.